from DBS Institute of Technologies, KAVALI. Today I am going to discuss presentation on metal forming process. So this is unit number 2, metal forming process. A product is produced by shaping the metal into the required shape and size. In mechanical working method, no machining process is carried out, but it is used to achieve optimum mechanical properties in the metal. By applying the force, the metal is plastically deformed into required shape. This deformation takes place when the stress caused in the metal reaches in the yield point. The mechanical working reduces the cavities present in the metal and also used to remove the impurities. The wastage of metal removal is negligible or too small, and production is high when compared to other manufacturing processes. Plastic deformation. If the solid body is loaded beyond the elastic limit, the body will be experience a permanent change in shape and size when if load is removed. Plastic deformation of metal and alloys is generally studied under two categories, namely plastic deformation of single crystals, plastic deformation of polycrystalline materials. So, plastic deformation of single crystals. Plastic deformation of single crystals involves the study of one single crystal and observing how it is behave under stresses. A single crystal is nothing but a single grain and has no grain boundary. Plastic deformation in single crystal may take place by slip, swimming, or a combination of both. Next, hot working and cold working of metals. The metal forming or working process are mainly classified into hot working and cold working process. The above division is on the basis of working temperature. Hot working of metal. The mechanical working of metal above the recrystallization temperature but below the melting point is known as hot working of metal. The recrystallization temperature of metal will be about 30 to 40% of its melting temperature. So, hot working of metals, you can see the figure. So, grain size it will increase in the hot working process. The increasing temperature is 100 degrees centigrade. So, the diagram will be given grain size and recrystallization temperature. So, semi-hot working or warm working. The drawbacks of both cold working and hot working process are eliminated by this method of working. In this method, the metal are deformed under the conditions of temperature and strain rate. The ductile tolerance yield strength factors should be considered for the selection of temperature and strain rate. The advantages of hot working. Force requirement is less when compared to cold working process. Toughness, ductility, and resistance can be improved. Quick and economical process. Porosity is eliminated and density of the metal is increased. It suitable for all metals. Disadvantages of hard work. Surface finish may be poor, close tolerance and automation cannot be achieved due to high working temperature. Tooling and handling costs are high. Sheets and wires cannot be produced. Next, types of hot working process. Hot forging. It can be defined as a metal shaping process in which a malleable metal part known as bullet or workpiece is worked to a predetermined shape by one or more processes such as hammering, upsetting, pressing, and so forth, where the workpiece is heated up to about 75 degrees of its melting temperature. So next type, hot extrusion. It is a production process used to form special steel profile with a constant longitudinal cross section. It acts through a force called compression. This process can be employed to manufacture solid or hollow profile bars with complex geometry and is fixed cross sections in a single step. Next, drawing. It is a metal working process which use tensile force to stretch metal, glass or plastic. As a metal is drawn or pulled, it stretches thinner into a desired shape and thickness. For wires, bars and tube drawing, the starting stock is drawn through the die is reduced in diameter and increased its length. So you can see the figure. Next, phasing. It is a forging process in which the dimensions of an item are altered using dies into with the items is forged. Phasing is usually a cold working process, but also may be hot work. Hot spinning. It involves spinning a piece of metal on lathe while high heat from the torch is applied to the workpiece. Once heated, the metal is in the sharp and the tools on the lathe process against the heated surface, forcing it to be destroyed as it spins. Next, cold working. The plastic deformation of metal to the required shape being performed below the recrystallization temperature is known as cold working process. The recrystallization temperature is about melting temperature, but generally cold working is called only at room temperature. So we can see the figure. Elastic deformation, plastic deformation and load in the vertical line. So deformation is horizontal line. So you can plot a graph on yield point, maximum load, cold working, fractions. The classification of cold working process. The drawing process. In drawing, we can divide it as blank drawing, wire drawing, cube drawing, embossing. Next, squeezing, coining, sizing, swapping, knurling, extrusion, bending, plate bending, roll forming, angle bending, seaming. So metals used for cold working process. Low and medium carbon steel, copper and light alloys, materials such as aluminum, magnesium, titanium, etc. Next, advantages of cold work. Widely applied as a forming process for steel, better surface finish is being obtained, provides higher dimensional accuracy, thin material can be obtained, it's suitable for mass production. Limitations. The surface finish may be poor, close tolerance can be achieved, stress formation in the metal during cold working is higher. Comparison between hot and cold work. So working above recrystallization temperature in hot working process. So below recrystallization temperature, cold working process. New crystals are formed after hot working, no recrystallization. It hardens the metal, no hardening in cold working process. Impurities are removed from the metals. In hot working process, impurities are not removed in cold working process. Elongation of metals take place in hot working process. Elongation is decreases in cold working process. Next, large size metals also deformed in hot working process, limited to size in cold working process. Surface finish is not good in hot working process. Good surface finish can be obtained in cold working process. Blowholes, cracks get welded during hot working process. Ductility is obtained during cold working and it is usable for machining process. Internal stresses is not formed in hot working process. Stresses formed in metal using while occurs in cold working process. Next, classification of basic sheet forging, sheet forming. So, sheet forming. Sheet metal forming involves forming and cutting operations performed on metal sheet, strips, and coils. The surface area to volume ratio of the starting metal is relative high. Tools include punch, die that are used to deform the sheets. So we can see the above diagrams. So bending sheet, deep drawing, shearing. So bending. In this, the sheet metal is treated by punch to give bend shape or angle shape, usually in a straight axis. deep or cup drawing. The formation of the flat metal sheet into hollow or concave shape like a cup is performed by stretching the metal in some region. A blank holder is used to clamp the blank of the die, while the push punch into the sheet metal, the sheet is drawn into the die hole, taking the shape of the cavity. Shearing. This is nothing but cutting of sheets of shearing action. Rolling. Rolling is a metal forming process in which the thickness of the work is reduced by compressive force exerted by two rolls rotating in opposite direction. Flat rolling is shown in figure, similar shape. Rolling is also possible like a square cross section is formed into shape such as I-beam, L-beam. Important technologies: bloom, slab, build. So bloom, it is a square cross section 150 mm into 150 mm or more. Slab, it is rolled from a I got or a bloom and has a rectangular cross section of 250 mm. Width or more and thickness is 40 mm or more. Built. It is rolled from the bloom and in a square in cross section with dimensions 40 mm on its side or more. So what is blooms? Blooms are rolled into structural shape like rails for railroad tracks. Billets. Our billets are rolled into bars or rods. They became raw materials for machining, wire drawing, forging, extrusion, etc. Slabs. Slabs are rolled into plates. So slabs are rolled into plates, sheets and strips. Hot rolled plates are generally used in shipbuilding, bridges, boilers, welded structure for various heavy machineries or heavy machines and many other products. So you can see the figures also. So we can bloom, you can use the L sections and I sections. So slab and billet. The plates and sheets are further reduced in thickness by cold rolling to strengthen the metal and permits a tighter tolerance or thickness. Important advantage is that the surface of the cold rolled sheet does not contain scales and generally superior to the corresponding hot rolling product. Later, the cold rolling sheets are used for stampings, exterior panels, and other parts used in automobile, aerospace, and household appliance industries. Rolling mills. Two high rolling mills. The types of rolling mills consists of two rolls rotating in opposite direction. Rolling diameter 0.6 to 1.4 meters. Type either reversing or non-reversing. Non-reversing mills. Rolls rotate only in one direction and slab always move entire. The slab always move from entry to exit side. Reversing mills. The direction of the roll rotation is reversed after each passes so that the slab can be passed through it both in both the directions. This permits continuous reductions to made through the same pace of rolls. Next, three high rolling mills. In this case, there are three rolls, one above the another at the time. For single pass, two rolls will be used. The roll direction will not change in the case. The top two rolls will be used for first reduction and the sheet is shifted to the bottom two rolls and further reduction is done. The cycle is continued till actual reduction is attained. Disadvantage: automated mechanism is required to shift the slab. For high rolling mill, this consists of two small rolls for thickness reduction and two large backing rolls for support the small rolls. The small rolls will reduce the roll force is required as the roll sheet contains area will be reduced. The large backing rolls are required to reduce the elastic deflection of small rolls when sheet passes between them. Next, cluster rolling mill. This uses smaller rolls for rolling. Tandem rolling mill. This consists of series of rolling sections of the order of 8 to 10. In each station, thickness reduction is given to the sheet. When each rolling station, the work velocity increases. This is fully used in industrial practice along with continuous casting operation. This result is reduction in the floor shape, shorter manufacturing lead time. Next, thread rolling. Thread rolling is used to create threads on cylindrical parts by rolling them between two dies as shown in figure. It is used for mass production of external thread parts like bolts and screws. Next, ring rolling. Ring rolling is a forming process in which the thick walled ring part of small diameter is rolled into thin walled ring of large diameter. As the thick walled ring is compressed, the deformation metal elongates making the diameter of the ring to be enlarged. Application: balls and roller balls and roller bearing races, steel tires for railroad wheels, rings for pipes, pressure vessels, and rotating machinery. We can see the diagram. Next, defects in strip rolling. Defects in strip rolling. Cracking defect, edge defect, weighingness, so light reduction, heavy reduction. So these are all the defects in strip rolling. Thank you.